Only mode.
Hello, good morning everybody. My name is Pradeep. I'm a technical manager representing Beacon North, based out of Delhi office. Today I'll be presenting SolidWorks for packaging machinery design. So machine design will be our core topic of discussion for today's webinar, and we'll be focusing on packaging machinery. So the technical jargon that I'll be using and the data set I'll be using will be very specific to packaging machinery. But again, pardon me if it's a little bit biased, but again, you can as well, uh, take away a lot of things from this webinar and apply to your own vertical, your own business focus. So let's get into the webinar without further delay. I have content worth of 35 minutes. So what I would like to do is, start it off with a primer using a PowerPoint presentation of 8 to 10 slides, not more than that. So once we are done with the PowerPoint, we'll quickly jump into SolidWorks and we'll see how SolidWorks can help you out, how you can automate your regular tasks in SolidWorks for your machine design. So the agenda for today's webinar, we'll start with taking a look at machine design process in general, the current or the conventional machine design process that people go through day in and day out. And then we'll see some of the challenges that the designers face. And then we'll talk about the benefits of using a robust 3D CAD solution like SolidWorks. At this point, I would jump into SolidWorks, do a live demonstration, show you some of the fantastic capabilities that SolidWorks has got, and then we'll come back and we'll discuss the ROI aspects and some of the success stories our customers have published with us. So this is a typical machine design process that we follow, which starts with RFP. It can be a RFP from your clients or customers, or maybe within an internal engineering department. So in either case, you have to be really quick. You have to get out a quotation. You have to get out some drawings, GA drawings maybe. So we'll see how SolidWorks can help you out in this phase. And then comes the real juggernaut mechanical design part, where you will be actually doing a lot of design from bottom up, where maybe some layout design is involved. Some of the component selection again is a very critical process in this flow. As you know, typical machinery, typical packaging machinery, has anywhere between 50 to 70% of components which are bought out items like motors, gearboxes, roller, conveyors, etc. So we will see how SolidWorks can help you out in this segment as well. And then comes the manufacturing and assembly part. So if you really are very careful at mechanical design part, and if you do basic validation like interference checking and collision checkings, and maybe structural design verification at the design stage itself, then your manufacturing and assembly part will be very easy, very error-free. And then you have to follow it up with a documentation stage where you'll be documenting your projects. Again, this is very, very critical, because most of the times, we'll be starting with an existing project and modifying it for a new requirement. So storing information or documenting information is very, very critical. Some of the challenges I was talking about, especially with an RFP stage, there are two prime aspects. One is time, second is accuracy. You have to give out or churn out a quotation really quick. At the same time, you cannot compromise on your accuracy. So your profitability really depends on how accurate and how precise your RFPs or quotations are. So most of the times, you'll be locating a similar job that you have done in the past, and then dig it out of your database and then start editing it, or preparing a similar quotation based on the work that you have done earlier for some other client. So locating a similar job and creating a proposal presentation is really important. So we'll be taking a look at e-drawings, which is a very, very powerful way of communicating your data. It can be 3D data or it can be 2D data. So this can be a differentiator. This can really This can really differentiate you from your competition. So, and then we'll move on to mechanical design, where we will be spending the core of our presentation today. We'll be talking about design changes. We'll be talking about how do you verify your or validate your designs before you get into assembly, and then some things like mechanical and structural design failure, revision control, etc., etc. We'll search for some standard components using 3D Content Central, which is a online database or a library of all the standard components. Because as I said earlier, anywhere between 50 to 70% of the components are bought out items, so it doesn't make sense for you to design those components of in-house. So instead, you can use databases like this, where you can just download, drag, and drop these components and still make use of them. A couple of reasons why I see this is important. One is for visualization aspects, as well as BOM related aspects, where you want to see these components in your designs, even though they are bought out items. Second thing is, if your assemblies or mechanisms are very if you're going to balance them, or if you want to have the accurate center of gravity and center of mass, so these things can come real handy. And then we'll get into the manufacturing assembly, where we'll talk about the accuracies in BOM, how important these are, the bidirectional compatibility, and then we'll talk about the documentation, as I said, where we have to sometimes create an end user manual. So I'll stop at this slide, benefits of SolidWorks solution. So at this point, I'll jump into SolidWorks, do a quick demo, and come back and then recap all this benefits, and then we'll have some time for Q&A as well. So the data set that I chose to use today is one of our customers' own data set. A customer is called Homiller. They are into packaging machinery. So we'll be talking about, or we'll be dealing with a flip-top closure closing system. It's a capping mechanism where you have bottles with flip-top caps, so which are automatically screwed and capped. So this is a product brochure. So I'll just quickly play a video to give you a sense of what we are dealing with today. So this is the Homiller capping machine video. It's an animation completely done in SolidWorks. I know the video will be a little bit chippy because you are watching it online, but you can see that there's a lot of camming motion going on. There's a lot of moving parts, mechanisms. This is an assembly which has slightly over 1,000 components. So I would say it's somewhere between mid to large assembly. And you can see what we'll be doing today is we'll be focusing on this underside area where we have a lot of gearboxes, motors, and some structural design happening. So we'll be working primarily in this area. So let me close this video and open up SolidWorks. What I'll be doing today is I'll be using SolidWorks 2013. So if you are using SolidWorks 2013, that's well and good. But if you are using SolidWorks 2012, 11 or older, you don't have to worry. Everything that I'm going to do today, most of the things at least that I'm going to do today, are very well there in the earlier versions as well. So that should not be a big problem. So let's start with something very simple like eDrawings. This is what I wanted to start with. eDrawings is a very powerful communication solution from SolidWorks, from Dassault Systems, which enables you to share 2D or 3D data with your customers. So what you can essentially do is you can share data with your customers, or your even within the organization also. Organization also you can share data. So in this I have a assembly drawing. You can see that I have a bill of materials. I have a total of 61 components of 40 different items, and then I have the couple of different views. You can see that there are some markups as well. So let's look into these markups. So e-drawings can be really used for review purposes as well. So the markup says assembly looks good so far. Need to add a motor and gearbox. Fair enough. And then the second markup talks about adding a drive to the rotary cam limit switch box. So from this we should be getting a ratio of 18:1. So there's a lot of work to be done here. So I'll quickly close this e-drawing and get into SolidWorks. So you might be wondering where this e-drawings came from, right? So it's nothing, it's very simple. All you have to do is publish a existing SolidWorks drawing into an e-drawings format. So the way you do it is going to File and Publish to e-drawings. So you can see that we have 40 line items and 61 number of components in this drawing. So let's get into the SolidWorks assembly environment. So as I said, we'll be primarily working in this underside area where you have some motors, gearboxes, cams, etc. Let's start with visualization. Visualization is really important when it comes to machine design because not at all point of time you want to see the complete assembly, because assemblies are usually very big. So what you want to do is you want to have something like display states where you can filter out components, we can change visualization properties. Like I have a couple of display states created here. One is for belt drive design. In this belt drive design visual display state, I have a mix of wireframe and solid geometry. So this really enables me to focus on the belt drive design part. And then we have a motor gearbox display state where I will just be focusing on the adding the motor and gearbox and adding some structural members to the existing components. So let's start with this motor and gearbox. So at this point what I would do is I want to add a gearbox and a motor to this existing assembly design. Again, as I said, these are bought out items, so I'm not going to design them. Instead what I would do is I would go to 3D Content Central. I don't know how many of you are aware of this. 3D Content Central is a supplier or user library which is hosted online, and where you can find content like all your bought out items. Here I'm on the 3D Content Central homepage, so where you can download or view all the components like cylinders, motors, valves, gearboxes, both supplier uploaded as well as user uploaded. So let's say I want to have a motor. I can dig into this, where now I have all the suppliers. You can see the suppliers listed on the right. I can click on any of the suppliers, and in the next page what I can do is I can really configure these components. Like in this case I can select the output speed. I can select the couple of other options, and then in the next page I even have some documentation that I can download and go through. And then 3D Content Central allows me to download this data in a wide variety of formats. Of course, here I need a 3D SolidWorks format. And the best part is you get to see a preview as well. And once you see the preview and once you're satisfied with it, what you can do is you can download this component and add to your SolidWorks assemblies. So here is a preview. So what you can do is you can download this and then use it in SolidWorks. So let's go back to SolidWorks. What I have done here is I have already downloaded the components that I need and I have placed them in my design library. So I'll just drag and drop this gearbox. As you see, as I drag and drop the gearbox, SolidWorks has automatically picked up some mates here. So it has picked up a concentric mate. Let's see what are all the mates that it has picked up. It I think has picked up a couple of mates. One is a concentric mate and one coincident mate. So you can see that these components are smart in nature. And let's add one more mate to make this face parallel to this one of the structural members. There you go. And up next, I need a motor. So again, I would go to SolidWorks. Usually I would go to 3D Content Central, but I have already downloaded. So what I'm going to do is I'm going to just drag and drop this. Again, SolidWorks has put the component in place. So no need of any additional mates, but what we need here are some fasteners to hold this in place. So the usual protocol would be to open up the catalog and go and verify the sizes of the hardware that we need, or the type of hardware that we need, and then we go to SolidWorks toolbox to pick those items. But a better way of doing it is right click on the component and click on insert smart features. Most of the components that you download from 3D Content Central excuse me, are smart components. So once you do it, SolidWorks will automatically go and look up the metadata which is stored inside, and it will dig up all the hardware items and features, if any, which are embedded inside it. So it's automatically figuring out the sizes and the type of screws that are needed. So all we have to do is click on OK, and now it is fastened in place. So a huge time saver. You can see that the motor and gearbox are still hanging in air, so we need to add some structural members. So what I'm going to do is I'm going to edit the existing part. What I would do is I would just create a simple sketch. SolidWorks has a lot of productivity enhancement tools like mouse gestures or shortcut toolbars. So I'm going to quickly draw a couple of lines. I'm going to leave some flexibility here. I'm going to draw one line shorter and the other one longer purposefully, so that I want to show you something neat. So let me get into my weldments toolbar, get into my structural members, pick the right size. I need a rectangular tube here. I'll just quickly select the sketch segments, but you can see that the segment is interfering with my gearbox component, as well as it's not rightly located. So for this we have something called as locate profile. Using locate profile, what I can do is I can click on or select the pierce point that I'm interested in, so that SolidWorks will place the structural member as such. And as I said, I purposefully made one of them longer and one of them shorter because I wanted to show you this fantastic command called trim extend. So here I'll just select the bodies that I need to be trimmed, and limits. So no need of getting your sketches exactly right. And the best part is SolidWorks has even coped up these structural members to my exact requirement. So a huge time saver again. So let's come out of this, and you can see that the motor, the gearbox is still in air, but not a problem because it has some smart capabilities inside. Some smart features are stored in. So in this case, you see that there's a plate and some hardware which are bundled with this, which means there is all this metadata stored inside this component. So all we have to do is select the reference it's asking. So it's asking me to select the face. So once I do it, SolidWorks will automatically bring in all this information, all the plate geometry along with the hardware items. There you go. So very, very powerful capabilities, these smart components. Maybe at the end of the webinar, I'll show you how to do it. So let's move on to the next part. The next part is where I would be focusing on the belt drive design. So I'll quickly change the display state so that I can focus on this belt drive design area. I would also hide this structural member because I don't need it, or maybe go one step further and isolate the components. best part about SolidWorks is you can really dig into your area of uh, uh, focus, and you can just start working in that area and forget about the rest. So here let me just show you the work which was done earlier. So here we have a bracket, we have a shaft, we have some bearings, we have some snap ring action going on, we have some pulleys as well, belt driven pulleys. So all the work on the top part is almost done, so we have to spend some time getting the work done on the bottom part. Before we go, I like to point out that the shaft is of 20 dia, and uh, and the bearing that we have used has is a SKF bearing, and let me just check the size. It's a 17 bore, so just to keep this in mind when we add new components. As you can see, this bracket is a little bit too longer for our shaft, or maybe the shaft is a little bit shorter for our bracket. Either case, we have to do some repair here. So what I'm going to do is I'm going to just edit this component and edit the sketch. Maybe add a dimension between the. So what I'm going to do is I'm going to over constrain this sketch. I knew it, but I want SolidWorks to solve it for me. One way of doing it is click on this over defined status on the toolbar status bar, and then click on diagonalize, so that SolidWorks will figure out a solution for us. So here it's giving us two solutions. One is getting rid of the dimension that we have just added. Obviously I don't want to do that. I'll go for the second one, where it's deleting a overall dimension. Let me quickly change this dimension to 5 millimeters. There you go. I think this is what I was looking for. And let's add a bearing. Again, I have stored it in my design library. And the best part about SolidWorks is capable of resizing components when you drag and drop them. As you can see, as I drag and drop this bearing part onto different faces, it's gonna resize, and you can also alter the orientation. This is fair enough. And as I said, the bearing here used for 17 bore has 17 bore. We checked it, so we can quickly make sure that we have a 17 bore by going into the component properties. There you go, and then we can just drag it out. And I think this is the right time where I can bring in some validation tools like interference detection and collision detection. So what collision detection does is it point out the colliding faces. You can see the faces in green are what are colliding. So there are both internal and external collisions. So this gives me a very good understanding of there are some changes needs to be done for the bracket, like in this case you can see that there is some undercuts and there are some extrude cuts done in the bracket to accommodate these bearings. Similarly, we have to get some work done here. So I'll just quickly mate this. And then what I'm going to do is I'm going to right click this component and insert some smart features. What this allows me to do is it allows me to add all the features which are stored in this. So you can see there are a total of 5 different features, like undercuts, shaft cuts, a housing bore, and a fillet for the housing bore. So all these are stored inside the component. So all I have to do is select the references. So the first component it's asking me to select is a bracket, and the second component is asking me to select as a shaft. So once I do this, SolidWorks is gonna do all the work for me. So it's inserting all the features. So if I go into my section view, you can see that SolidWorks has chiseled out the bracket to accommodate, and it has also got the undercuts done for the shaft. So a huge time saver. Up next, what I would do is I need a retaining ring. So I'll just drag and drop it onto the surface, which allows me to resize and then quickly mate it in place. Again, we need a undercut, or we need a groove for this retaining ring. So again, you can see that it's a smart component. So insert smart features, select the bracket, and we should be good to go. There you go. We need a wrench flat. Wrench flats are the features. It's not a component. So in SolidWorks Design Library, you can save some features as well. And you can drag and drop it onto the component. Of course, we should be in edit component mode for this to happen. Let me go into Design Library again, pick the wrench flat and drag and drop it onto the shaft. So SolidWorks is asking you to click the locating edge from which it will be dimensioned. There you go. And since everything is parametric, we can change the dimension to get it right. We need to add a couple of components here. 30/60 pulley wheel. And along with the pulley wheel, we need some bushings to hold it, and we need some hardware as well. All this information is stored inside the pulley, so all I have to do is click on Insert Smart Features. You can see that SolidWorks is going to place all these components, which looks absolutely fine. Up next, we need a key shaft here. So let's insert the key shaft. So it's asking us for a component for reference, which would be the shaft. And upon clicking this, I have my keyway in place. I'll just quickly accept this and show you the power of top-down modeling approach. So you can see that there's a feature cutout to accommodate the keyway. So when I move this, the feature, the cut which accommodates the keyway will also move accordingly. So a real handy tool. So what I'm going to do is I'm going to constrain a little bit here. I'm going to add a perpendicular relation between these two faces, one of the wrench flats and then the keyway face. And the only thing that needs to be constrained is the vertical distance, which will be taken care when we are going to put in the belt. So for this, I need to come out of the isolate because I need the other components as well. I need the planes, reference planes, so I'm going to unhide them. And then I'm going to mate using these two planes. I need them in the same plane. And I can get rid of the planes now. So let's add the belt now. In SolidWorks, if you want to locate a particular command, you can make use of the command search, which is a powerful option. So I'm going to use the belt command. All I have to do is select the arcs or the faces which are in the same plane, and SolidWorks will create a belt for me. And you can leave some flexibility. And in this case, I have left some flexibility so that I can decide how and where my belt is gonna be. So in this case, let's say we use a particular specific length, belt length, like let's say 900 mm. We can make it a driving parameter, and we can create a new part for the belt so that we can give it some material, and we can give it some geometry as well. So if you see in our assembly tree, we have a belt component, which I'm gonna edit and give it some geometry. It's a thin component, let's say 2 millimeters thick and 12 millimeters wide. Let's make it a mid-plane extrusion. There you go. And what we can do is we can give it a nice we can assign the material so that the texture will automatically be taken care of. This is good for a couple of different purposes. One is you get your accurate bill of materials, and the weight calculated will also be accurate. So we're done with our belt design. So you can, if you can see, if I yeah, so if I move this component, you can see that SolidWorks has you can see that SolidWorks has incorporated motion. You can see that all the belt drives are moving as expected. So this is one of the benefits of using a 3D CAD package like SolidWorks. So now I'm gonna just turn on the rest of the components, and I'm gonna go back to my assembly drawing, where I want to show you a couple of things. First thing I want to show you is the bill of materials. When we started, we had 40 line items and a total of 60 components. So now you can see that the bill of materials is updated. So there's a real-time bi-directional connectivity between our assemblies and our drawings. So you can see that the bill of materials is updated. So all the new components that we added right from the gearbox are added here. So we have a total of 47 line items and 74 components. And you can see all drawing views are also updated. So we might need a couple of new balloons. So we can do it either manually, or we can do it automatically. Like in this case, I have a lot of components going on in this belt drive area. So I can create a new section view. Creating a section view might be a little bit different in 2013. We have a new interface for creating section views, but the overall methodology remains the same. So I don't want the full section. Let me control the depth as well. So that was, let me place this somewhere, and then I'll start controlling the depth. I think this is more like what I needed, and I can control the size. Oops, there's something wrong with this. Let me just quickly delete this and add a new section view again. Yep, and let's now include section depth. Yeah, this is more what like I wanted, and we can even get a step ahead, and we can crop this to our area of interest. What I want to do next is just quickly change the scale, maybe 1:5. And then quickly add balloons, but this time I'm not going to do it manually. What I'm going to do is I'm going to use the auto balloon capability of SolidWorks. There you go. So very powerful, you can say, detailing capabilities in SolidWorks. When I'm done, what I'm going to do is I'm going to quickly publish to eDrawings and share this information with my customer or my manager who has no CAD system on their PCs, but they are still able to view this in 3D as well as 2D, so which is a quite a powerful capability. So this is what they get and I can play out the views. Even though it's a 2D drawing, you get all the 3D capabilities. What I can do is I can quickly stop, I can zoom, pan, rotate. So this is all fantastic capabilities inside SolidWorks, which is called as eDrawings Professional. So I'm gonna just quickly wrap this up. I think we are right on time. I would like to take some Q&A, but before that, what I would like to do is I would like to show you how smart components are done. If you have any questions, you can just let me know by uh, entering your questions in your chat window or the questions panel. Just give me a couple of minutes when I can just locate the files. If you have any questions, please let us know, and we'll get back to you.